Hello and welcome to the video. Matthew here, and we're going to look at question 9, which is a 50-mark question on functions and calculus. So we're told that when testing rockets, NASA uses an aircraft to carry the rocket to set height before dropping the rocket into freefall. Its thrusters are then engaged and the rocket begins to gain height. So then Wiki, who is a rocket scientist, models that the height of the rocket in kilometers is given by the function s of t, which is equal to the square root of a over t plus t over a, where a is a constant between 0 and 60, and then t is the number of seconds after launch. So then a part 1, which is worth 10 marks, wants us to show, using calculus, that the speed of the rocket after t seconds is v, which is equal to ds dt, which is equal to 1 over a minus a over t squared, over 2 square root of a over t plus t over a. Now the formula s of t is the distance, and to go from distance to speed you can differentiate. So here we're told that the speed of the rocket is given by ds dt, which you may not always be told this. So just keep in mind that if you're given the function to find the distance, to find the speed, just differentiate that function. Now if you're given the function for speed and you want to find the function for difference, just integrate the function for speed and that will give you the function to find the distance. So now let's differentiate st. Now the square root of a over t plus t over a is actually the same thing as a over t plus t over a to the power of a half. So I'm going to write it like that to make it easier for us. So now I'm going to substitute in u for a over t plus t over a. So then I'm going to write s of t is equal to u to the power of a half, where u is equal to a over t plus t over a. So now I'm going to use the chain rule to find ds dt. So I'm going to get ds du and multiply that by du dt, and this will give me ds dt. So now let's differentiate s of t with respect to u. And u to the power of a half differentiated with respect to u is going to be a half u to the power of minus a half. And now I'm going to rewrite u as at to the power of minus 1 plus ta to the power of minus 1, as this makes it a bit easier to differentiate. And then differentiating u with respect to t, so I have at to the power of minus 1. So you bring down the minus 1 and then reduce the power by 1. So that's going to give us minus at to the power of minus 2. And then ta to the power of minus 1. So here the a to the power of minus 1 is just a constant. So that means the t will just go and we'll be left with a to the power of minus 1. Now I'm going to rewrite this as minus a over t squared plus 1 over a. And that's my du dt. And I've already gotten my ds du. So now I'm going to multiply my ds du by my du dt. So a half u to the power of minus a half is the same thing as 1 over 2 square root of u. And I'm going to multiply that by minus a over t squared plus 1 over a. And now substituting in a over t plus t over a for u. So now multiplying minus a over t squared plus 1 over a on top, and then filling in a over t plus t over a for u, I'll be left with minus a over t squared plus 1 over a over 2 square root of a over t plus t over a. And that's exactly what we had to show at the start of the question. So minus a over t squared plus 1 over a is the same thing as 1 over a minus a over t squared. So even though I've them in a different order, it's the exact same sum. So that's our answer for a part 1. Now let's have a look at a part 2, which is also worth 10 marks. So this says that given that the height of the rocket 30 seconds after launch is 2.7 kilometers, show that the value of a correct to 3 decimal places is 4.196. So we know that the formula for the distance is given by the square root of a over t plus t over a. Here t is going to be equal to 30 and the function itself will be equal to 2.7. So if we do the square root of a over 30 plus 30 over a and put that equal to 2.7, we should be able to solve for a and show that a is equal to 4.196. So now I'm going to square both sides to get rid of the square root sign, and I'll be left with a over 30 plus 30 over a is equal to 7.29. And now to get rid of the fractions, I'm going to multiply by the lowest common denominator, and the lowest common denominator here is going to be 30a, as there's no obvious answer, so we can multiply the 30 by the a. So I'm going to multiply all the terms by 30a. So 30a by a over 30, both the 30s will cancel, and it'll be a by a, which is obviously just going to be a squared. And then 30a by 30 over a, both the a's will cancel here, and it'll be 30 by 30, which is obviously, and it'll be 30 by 30, which is 900. That's going to be equal to 30a by 7.29, which is equal to 218.7a. So now rewriting that, I'm going to get 1a squared minus 218.7a plus 900 is equal to 0. And now I can use the minus b formula for this. And the minus b formula here will give us the roots of this quadratic equation. It's on page 20 of the Formula and Tables book. So it's minus b plus minus the square root of b squared minus 4ac over 2a, where a is the coefficient of the x squared, b is the coefficient of the x, and then c is the constant. If we fill these into the formula, we should get our two values for a, and only one of them will work. So we just need to fill these into the formula, and then we should get our values for a. So our a here is going to be 1, as the coefficient of the a squared is just 1. So keep in mind that a squared is the same thing as 1a squared. Our b is going to be minus 218.7, and our c is going to be plus 900. So then popping these into the formula, so minus b is going to give us 218.7 as it's going to be minus by minus. Okay, plus minus the square root of b squared, so minus 218.7 squared, minus 4 by a, which is 4 by 1, by c, which is 900, and all of that will be over 2a, so all over 2 by 1. So now evaluating the bit underneath the square root sign, so minus 218.7 squared minus 4 by 1 by 900 will give us 44,229.69. That's going to be 218.7 plus minus the square root of 44,229.69 all over 2. So now splitting this up into 2, we'll get 218.7 plus the square root of 44,229.69 over 2, and 218.7 minus the square root of 44,229.69 over 2. So now evaluating 218.7 plus the square root of 44,229.69 over 2, we get 214.504, corrected 3 decimal places. And then changing the plus to a minus, we get 4.196, correct to 3 decimal places. Now remember at the start it said that a had to be between 0 and 60, therefore a is not equal to 214.504, as obviously that's bigger than 60, which means a must be equal to 4.196, and it's only equal to 4.196. Now let's have a look at a part 3, which is also worth 10 marks. So this says that the local residents wish to know how close to the ground the rocket will fly. The minimum height occurs at the only turning point where t is positive. So now we're asked to calculate the time after launch that the minimum height occurs, correct to 3 decimal places. So to work out a turning point, which is either a minimum point or a maximum point, we get the first derivative and put that equal to 0, and then solve for the variable, which in this case here will be t. So we've already worked out our ds dt, and that's 1 over a minus a over t squared over 2 square root of a over t plus t over a. And now I'm going to put that equal to 0. So to get rid of the fraction, I'm going to multiply both sides by the denominator, which is going to be 2 square root of a over t plus t over a. So the 2 square root of a over t plus t over a will cancel with the 2 square root of a over t plus t over a, and I'll be left with 1 over a minus a over t squared. And 0 by any number is always going to be 0, so it's going to be 1 over a minus a over t squared is equal to 0. Now remember, we know what a is, it's 4.196, so therefore 1 over 4.196 minus 4.196 over t squared. And remember, we know what a is, so that's going to be 1 over 4.196 minus 4.196 over t squared is equal to 0, and we're going to solve for t. So we're going to move the minus 4.196 over t squared over to the other side. It's going to go over as a positive. So it's going to be 1 over 4.196 is equal to 4.196 over t squared. So now I'm going to do cross multiplication. So it's going to be 1 by t is equal to 4.196 by 4.196. And 4.196 by 4.196 is just 4.196 squared. So that's going to be t squared is equal to 4.196 squared. And if I get the square root of both sides, that will give me t is equal to 4.196. And of course that's in seconds. So there we have it, the minimum height occurs after 4.196 seconds. So that's our answer for A part 3. Now let's have a look at A part 4, which is worth 5 marks. So this wants us to find the minimum height of the rocket, correct to 1 decimal place. So we have the formula for the height of the rocket after a certain amount of time, which was given at the start. So we know what A is now, we know what T is, so we just have to fill in A and T into the formula, and then evaluate to work out the minimum height of the rocket. So A is always going to be equal to 4.196. And t at the minimum height is going to be equal to 4.196 as well. So popping this into the formula, we're going to get the square root of 4.196 over 4.196 plus 4.196 over 4.196. So 4.196 divided by 4.196 is just going to be 1. So that's going to be the square root of 1 plus 1, which is equal to the square root of 2. And correct to 1 decimal place, the square root of 2 is equal to 1.4. So therefore, the minimum height of the rocket is going to be 1.4 kilometers. So that's our answer for A part 4. Now let's have a look at the final part of the question, which is worth 15 marks. So this says that the fuel tank on the rocket is cylindrical in shape. From a sensor fitted inside the tank, Wiki, who's the rocket scientist, can determine that the rate of change of the height of the fuel in the tank, which is given by dHdt, is equal to 16 over pi meters per second. So now we're asked to find the rate of change of the volume of the tank in terms of ore. So the rate of change of the volume of the tank in terms of ore, so the rate of change of the volume is going to be dV dt. So we're going to use the chain rule here to work out dV dt, and normally in rates of change questions you will use the chain rule. So the chain rule says that dV dt is going to be equal to dV over something multiplied by that same something over dt. So both those green dots there must be the same thing. Now we have dH dt, so if we fill in dH for the green spot, then we'll already have one of the things that we need. So let's do that. So we're going to say that dV dt is equal to dV dH by dH dt. We already have dH dt, so we just need to work out dV dH. So let's see now what the formula is for the volume of a cylinder. So this is on page 10 of your formula and tables book, and it's the second formula down. V is equal to pi r squared h. So to work out now what dV dH is, we need to differentiate V with respect to h. So differentiating pi r squared h with respect to h, we just get pi r squared, as the h will just cancel, as it's just h to the power of 1. So now we have dv dh, and we also have dh dt, so multiplying pi r squared by 16 over pi will give us dv dt. So pi r squared by 16 over pi, both of the pi's will cancel, which leaves us with r squared by 16. So therefore our answer is 16 r squared. So the rate of change of the volume of the tank in terms of r is 16 r squared. And that's your answer for part B of the question, which is the final part of the question and the end of the video. So thank you very much for watching, and I hope I helped.